All right, so today we're going to be taking a deep dive into the world of conducting polymers.
Yeah.
And so this is based off of an article that we read by William L. Weaver in Scientific Computing and Instrumentation from June 2003.
Yeah.
And just to get started, what are conducting polymers?
So conducting polymers are they're polymers that have alternating single and double bonds between carbon atoms.
Okay.
And this allows them to conduct electricity.
So instead of being insulators, like we usually think of plastics as they actually can have charge flow through them.
Exactly.
Yeah. And so Weaver talks about this concept of doping and how that affects conductivity.
Yeah, so doping, basically, it's kind of like adding impurities to the polymer.
Okay.
And these impurities can either accept electrons or donate electrons.
Right.
And so that increases the number of charge carriers.
Okay.
Which is what allows electricity to flow more easily through the material.
So it's kind of like if you're thinking about like a highway and you're adding more cars to the highway so you can move people through faster.
Yeah. Exactly. Yeah, it's a good analogy.
Okay. And so Weaver also talks about how these conducting polymers can be used in like an electronic nose.
Yeah.
So how would that work?
So an electronic nose is basically a sensor that can detect different vapors, and it does this by measuring the change in conductivity of a composite material.
Okay.
And so this composite material, it's usually like a polymer matrix with like small particles of a conductive material like carbon black dispersed in it.
Okay.
And when this composite material is exposed to vapors, the polymer will either absorb or release those molecules.
Okay.
And this causes it to either swell or shrink. And this changes the concentration of the charge carriers in the material.
So the more it swells or shrinks, the more it changes the concentration of the charge carrier.
Yeah.
Okay, and that changes the conductivity, and so then you can measure that change.
Right, exactly.
And that tells you something about what you're sensing.
Exactly, yeah.
Cool. And so he gives an example of using like nitric acid solution in that matrix. And so is that is it because it have a lot of ions in it?
Exactly, yeah. So a higher concentration of ions in a solution means that it's going to have more charge carriers.
Okay.
And so it's going to be more conductive.
Gotcha. Okay, cool. So that's a pretty clever way to make a sensor.
Yeah, and it has a lot of different applications.
Yeah, it does. So what are some other applications of electronic noses?
So, well, one example is detecting spoiled food.
Okay.
But you can also use them to monitor air quality. You can use them to detect explosives.
Wow.
And even diagnose diseases by analyzing someone's breath.
That's really cool. So it's like a whole new way of sensing the world around us.
Yeah, exactly.
And so Weaver mentions one specific conducting polyaniline.
Yeah.
And what makes that one so special?
So polyaniline is really cool because it's actually naturally conductive.
Okay.
So unlike most conducting polymers that need to be doped, polyaniline is conductive right out of the box.
So you don't need to add any extra impurities.
Yeah, you don't need to add any extra charge carriers.
That's pretty impressive.
Yeah. And but what's even more interesting is that we can still dope polyaniline to fine-tune its properties.
So you can still like tweak it and get it to do exactly what you want it to do.
Exactly. Yeah.
Okay. And so how does that work?
Well, it's similar to how we dope silicon, which is the main material used in traditional electronics.
Okay.
So you can dope silicon to create two types of semiconductors, P-type and N-type.
Okay.
And so P-type semiconductors, they have holes which act as positive charge carriers.
Okay.
And N-type semiconductors have extra electrons which act as negative charge carriers.
Gotcha. So you can almost make it like have a positive charge or a negative charge depending on how you dope it.
Right, yeah. And we can do the same thing with polyaniline.
Okay.
We can dope it to create P-type and N-type polyaniline.
So that sounds like it opens up a lot of possibilities.
It does, yeah.
Cool. So what are some of the applications that we can use that for?
Well, one example is OLEDs, which are organic light-emitting diodes.
Okay.
And those are used in like high-end TVs and smartphones.
Oh, yeah. The ones with the really nice screens. Okay.
Exactly. And so conducting polymers like polyaniline can actually be used to make these OLEDs even more efficient and flexible.
So the bendy screens that we're seeing more and more of.
Exactly. Yeah.
Wow. That's really neat. And Weaver also mentions a couple other technologies, ChemFETs and ChemCaps.
Yeah.
What are those?
So those are basically just highly specific sensors.
Okay.
So ChemFETs are chemical field effect transistors.
Okay.
And ChemCaps are chemically sensitive capacitors.
Gotcha.
And they can be used to detect very specific molecules.
So like if you were trying to detect like a specific disease or something, you could use one of those.
Exactly. Yeah, they have a lot of potential applications in medical diagnostics and environmental monitoring.
Wow. So it seems like we've barely scratched the surface of what conducting polymers can do.
Yeah, I think we're just getting started.
Yeah. So let's take a quick break, and then when we come back, we'll dive into some of the future possibilities of this technology.
Sounds good. So we've talked about all these amazing things that conducting polymers can do, but it's kind of mind-blowing to think that back in 2003, when Weaver was writing this article, some of these things were just like science fiction, you know?
Yeah, I mean, it really makes you wonder, like, 20 years from now, what are we going to be talking about?
Yeah.
So, what other, like, futuristic applications do you think are on the horizon for these conducting polymers?
Well, one thing to think about is that, like, now we have the ability to manipulate materials at the nanoscale.
Uh-huh.
So we can actually create materials with specific properties that we want.
So instead of just finding these materials that already exist, we can actually make them from scratch.
Exactly. Yeah.
Wow, that's pretty amazing.
Yeah. And so, one area where this is really exciting is in the development of like biocompatible materials.
Biocompatible, so like they could actually interact with living tissue.
Exactly.
Yeah, that sounds like something out of a movie.
It does, but, researchers are already looking into using conducting polymers in things like medical implants and biosensors.
Wow, so instead of having these like big clunky implants, we could have devices that are like seamlessly integrated with our bodies.
Great disaster.
And sensors that can like monitor our health in real time.
Yeah, that's the idea.
That's incredible. And earlier you were talking about flexible electronics.
Yeah.
Like, what kind of possibilities are there for conducting polymers in that area?
Imagine like wearable sensors that are woven directly into your clothing.
Okay.
And these sensors could constantly monitor your vital signs, your physical activity, even your stress levels.
Clothing that can sense our emotions.
Yeah, it
Yeah.
sounds kind of creepy.
Yeah, a little bit.
But it also kind of highlights the potential for like blurring the lines between technology and our own bodies.
Yeah, like we're becoming more and more like cyborgs in a way.
Right.
And that makes me think about those electronic noses that we were talking about.
Yeah.
Could they actually evolve to become like even more sensitive than our own noses?
I think so, yeah.
Like, what would that look like?
Well, imagine sensors that can detect like trace amounts of pollutants in the air, or even identify like the early signs of disease long before any symptoms appear.
That would be amazing.
Yeah, or even like, analyzing the chemical composition of distant planets.
So we could use them for space exploration too.
Exactly.
Yeah. It's incredible to think that something as simple as a change in conductivity could have such far-reaching implications.
I know, it's pretty mind-blowing.
Yeah, it seems like conducting polymers have the potential to like solve some of humanity's biggest challenges.
Yeah, I definitely think they do, and I think we're just scratching the surface of what's possible.
Well, this has been a really fascinating deep dive,
It has.
and I think we've given our listeners a lot to think about.
Definitely.
It's pretty amazing to think about how these materials could really change the world.
Yeah, it is, and we've really only just scratched the surface of what they can do.
I know it's kind of mind-blowing to think that back in 2003, when Weaver was writing his article, some of these things are just like pie-in-the-sky ideas.
Yeah, right?
And now we're talking about them like they're right around the corner.
Yeah, and who knows what kind of amazing new discoveries are waiting for us.
Right, yeah. So, what advice would you give to somebody who's listening to this and they're like, wow, this is really fascinating stuff. I want to learn more.
I would say pay attention to the intersections.
The intersections.
Yeah, like conducting polymers, they're not just about chemistry or physics or materials science.
Yeah.
They're about all of those things coming together.
Okay.
And I think the most exciting breakthroughs are going to come from people who can bridge those gaps and see the bigger picture.
So it's like a reminder that innovation often happens at the edges of different disciplines.
Exactly.
That's a really good point.
Yeah, so, don't be afraid to explore and connect the dots and ask questions that might seem crazy at first.
Right.
You never know. You might just stumble upon the next big thing.
Yeah, that's great advice. I think we've given our listeners a lot to think about today.
We have.
We started with this idea of polymers that conduct electricity, and we ended up talking about all these amazing possibilities for the future.
Yeah, from medical implants to biocompatible sensors to clothing that can sense our
And
emotions.
it's been quite a journey.
It has, and it's just the beginning.
So to all our listeners out there, keep exploring, stay curious, and who knows, maybe you'll be the one to unlock the next chapter in this incredible story. Thanks for joining us on this deep dive.